Hello, in this video we will work the ancient Fisher cube. It's a puzzle that is a little bit more complex than the Fisher cube that we already worked and the windmill. The strategy is the same. We will always work this middle layer first, and then we do bottom and then top at the end. So we have, in fact, in this mid layer, it's a little bit particular. We have this line here where we have kind of three pieces. We have this center and these pieces. They are oriented, so they can be put. It's like the corners in a classic 3x3. They can be wrongly oriented like this. So I have to put it back in the previous orientation. So these pieces should be fitted here correctly, not in any way. This center also can be put on the top, and I can put another piece here. So I have the center that was here, it is on the top, and the other center of the top and bottom are still in their place. So this cannot be done on this cube. I cannot move the center from this layer to the top without disturbing the white and yellow centers of bottom and top. So this is a little bit particular. And then we have this piece here, which lives alone, let's say, and this one here. So also we have problems of parity on this cube. We can solve everything, and at the end we have a kind of parity problem. We have to break it. Also, we could have a problem in the cross elements or the edges. It's like this, and this. We could have situations where, in fact, we only have one edge that has to be flipped, whereas in a classic 3x3, we always have two pieces here that have to be flipped. Okay, so I will start to scramble it, and then we will see when we meet some of these problems how to deal with them. Okay. It's not very easy to move a puzzle, because we have to always align the layers of the centers so to be able to move. Also, while scrambling, let's say that we have this piece here that is not three pieces, it's only one piece. So this is the active part, and these two are attached to it. And this is one piece, not two. This is the active part, and this is attached to it. And this is one piece, not two. They are attached. Okay, so we have to pay attention to some pieces that look that they are several pieces, but in fact it's only one piece. Okay, let's say it's a scramble. So we have white on the top, we have yellow here. We have to put the center, we have to build first this mid layer, when we have to put the centers here. So I have, okay. Not very easy in the this guy here. Okay, I have this, I think this is the center, so I will try to put it like this, like this. Okay, we have to start in some place, and then we will just to give it a shape, let's say. So these should be must be replaced by orange. Okay, and this. And this. Okay, this orange, I will put it here, put it there, and then it should belong here. Okay, I will rotate it first, and it is here. Okay, so this red, I will try to put it here. Okay, but I see that I have to rotate it. So I put it on the top. I rotate and I put it down. And here it is in its place. This red should be rotated. I put it up, I rotate, and I put it down, and I have this line correctly built. Let's see the other line. Okay, we'll do like this. This is should be rotated, so I put it up, I rotate, and I put it down. Okay, we have this orange line, we have this red line. Now we have to put the green and blue. So I move away. I should put this here. So it's very simple. There's no algorithms. It's really not easy to move. Okay, and down. And no, it should go like this. So okay, I got it here, and now I have to put this here. So I go like this, and this, like this, and like this. Okay, I have built this middle layer. So I'm not quite sure that red is here and orange is here. So this is probably where the parity would come from. At the end, we should replace the pieces and rebuild this central layer to break some parity problems. Okay, once we have done this middle layer, okay, I think the puzzle has now a shape that is more easy to handle. Let's build or flip correctly the elements of the cross. So I have this element of the cross here. I have this is correct, this is correct, this is correct. Okay, let's flip these two. Okay, we do it like, in fact, when we do a flip of. We have this kind of situation. We have to flip these two. So the algorithm is up, U prime, down, down. So this is what we should do here. Okay, I will flip this and this to get white and yellow on the top. So it's up, U, up, U prime, down, and down. Okay, I flipped these two. Now let's look at what happens here. We see that we have 3 elements of the cross, or 3 edges that are correct, and only one that is not correct. This is very atypical We cannot have the situation in a 3x3 classic cube. So to get rid of this situation, what we can do is we can put this piece here, we can put it there, okay, and then the piece that was here and we put it down on the bottom layer, we will put it again in its place with the same algorithm that we generally use here. For example, if I want to put this piece there, I have this algorithm. Okay, and then the piece that was kicked is this one. I have to put it again here. So what I do is repeat the same algorithm. Okay. Oh, I got it wrong. I should have done it in another way, but you got the point. So this is the algorithm that we will use. Okay, so this piece should go there. So how do we do? Okay, we move away, down. Okay. Now, this center that was here, I will put it back in its place. With the same algorithm. I got it back in its place, and if I look at the cross elements, I see that they are now correct. So they are all correct. Okay. So in fact, the thing is not to, the element of the cross should be exchanged with this and not this element, in fact. So this piece should be exchanged with this center here, using the algorithm that we use on a 3x3x3 to exchange edges, not centers. So it's a structure that is a little bit particular. So the center that is here can be kicked from its place and moved to another layer. We already said that in the beginning. So if you have a problem with this cross element, where you have only one cross element that it has to be flipped, all you have to do is to exchange it with a center, with the algorithm that we use on a 3x3x3 to exchange this piece from here to there, and then put again the center in its place. And this will solve this atypical problem of the elements of the cross. It's a kind of parity problem, but now we have solved it. Okay. So now we move to placing the elements of the cross in their correct positions. Okay, I have to always pay attention to have this parallel. This piece should be parallel to this. So now I have to put orange here. Okay, I will put it like this. Okay, this orange will go correctly here. Okay, so I move it away. I move 2L, yes. I move it back, 2L again, and I got it correct in its place. And I did not disturb or destroy the mid layer. This is very important. You have to always keep the middle layer correctly built. You should not destroy it. Now I will put the red. So the red, in fact, this will go correctly here. So I move it away. I move 2R. I move it to its place, and I got it correct here. And now this red will go here. I move it away, 2L, and I move it down. And I have built the elements of the cross. Now I have to put the edges. This is an edge. This is only one piece, in fact. Okay, it's like this. This is only one piece, and it should go here. So I will remove it from here, from the bottom to the top, and then I will try to flip it and then put it back in its correct place. Okay, what I will do first is I will try to see. Okay, all the yellow elements are not correctly flipped. So I will try to put them on the top layer and flip them correctly and then put them back in the bottom layer. Okay, so I will remove this from here to up. I will put this piece down. The algorithm is, you know, it's 2R, U, 2R, U prime, 2R. But the problem is when we use this algorithm, we flip this middle layer or we reverse it. It should be like this. So to get it back to its normal position, we have to repeat this algorithm on the same side, not on another side. So I will use it, for example, to remove this yellow piece from here and put a white in its place like this. Oh, 2R, U, 2R, U prime, 2R. Okay, I have put all the yellow elements on the top and I have kept this mid layer correct. Now to flip these corners, we use the algorithm that flips corners. You know, if I want to flip this, I put this yellow on the top, I use the up, U prime, down, U prime, okay, and it's flipped and it goes from here to there. So this is what we will do. Okay, I will flip this and it's this algorithm. So it's up, U prime, down, U, down, U prime. Okay, before flipping the others, I will start to put these correctly in their places. I see that this belongs to there, in fact. So I will put it here using the algorithm 2R, U prime, 2R. It's correctly fitted. Now I have to reverse this by putting another piece, let's say the green. It should belong there. 2R, U prime, 2R. Okay, I got this correct in its place and I have reversed correctly the mid layer. Now I will flip the yellow pieces. This one, I will flip this and maybe this. Okay, so up, U prime, down, U, and down, U prime. Okay, the two yellow pieces are correctly flipped. I put first the red in this position. I flip the center. I have to repeat this algorithm on this side. So I know that I have this blue that should belong there. So I do 2R, U, 2R prime, and 2R. And I have built these bottom and mid layer. Now I have to build the top layer. First, we have to do the cross. In fact, this is an element of the cross. This is an element of the cross. It's the same thing that we do when we have to build a cross here. Okay, let's put things correctly. Okay, so if you want to put, let's say, we have it correct. So when you have to permutate or cycle these three, you put a correct element of a cross here, and then you do an algorithm that permits to move this from here to there, and this from here to there, and this from here to there. Okay, so it's up to U, down, U, up, U, down, and I have all the elements of the cross in their position. So here we have to put only one element of the cross, which is here. It's in its correct position, and I have to do an algorithm that permits to move this from here to there, and the others will go correctly in their place. So I have to do it from here, up to U, down, U, up, U, down, and As you see, this is correct, this is correct, and this is correct, this is correct. I have built the cross. Now I have to take care of the edge, of the corners. So the corners, like any 3x3, we try to see if we have one corner that is correct, and then we place the other 3 in their correct positions. So here I see that I have the red, which is correct. Okay, blue is correct, and these 2 are not correct. So that's quite good because we have a parity problem. Okay, so I will solve the or flip the pieces so you can see really the parity problem, how it is. So how to flip this is to do the algorithm that goes like up to U, down, U, up, U, down, and then from the other side we repeat it, up to U, down, U, up, U, down. I repeat it again, up to U, down, U, up, U, down, and from this side up to U, down, and okay, I have flipped these 2, and here I will flip these 2 also, up to U, down, U, up, U, down, up to U, down, U, up, U, down. Okay, so all the corners are correctly flipped, but I see that I have these 2 that need to be exchanged, and it's a parity problem. Whatever I do, if I exchange these, for example, by doing what we do on a 3x3x2, if I want to exchange like these 2 corners, I will create a problem in the mid layer, so it will not solve my problem here. So what we should do, in fact, is we have to rethink how we built in the first place this middle layer. So the thing to do is to exchange these pieces. So generally what I do is I put this here and this here, and I move this center. I will try this from here to there. Well, not quite sure. Okay, I will try just to put this orange that was here in this place. I will keep these centers. So it's like this. It's like this. And this guy will go here, and this like this. Okay, and now these 2 need to be in their correct positions. Okay, so we will see if this solves our problem. So I need to flip these 2. Okay, now flip these 2. Okay, now we solve again. So I build the cross. No. This is correct. The last element of the cross is here. Back. Okay, I have the cross that is correct. I put orange. This orange, I put it down. Okay, it's correct. I have to flip this, so I'll do it by exchanging these two. Okay. Okay, now I have to flip this and this, up U prime, down U down. Okay, this is correct. I try to put this in its place. It should belong here. So it's 2R U prime 2R, and I will put like this piece down. Just to reverse this layer. Okay, now this can go correctly here. 2R U 2R prime 2R, and now I will put this down. 2R U prime 2R. All I need now is to flip this piece, so I will flip it up U prime, down U prime, and I will put it there. But first I will put any other piece here, and then I repeat the algorithm in order to get the mid layer not reversed. 2R U prime 2R. Now I get the good one. 2R U prime 2R, and I have built these two. Now I move to the top layer. Okay, I have the elements of the cross that are correct. Okay, let's keep them. And I have this red correct, this blue correct, this orange correct, and this green correct. All I have to do now is to flip the corners, doing the algorithm. You know, it's up to U, down U, up U, down, and I repeat it from the other side. Up to U, down U, up U, down. Okay, I got these two correct. Now I have to flip these two. I have to repeat this algorithm twice, in fact. So up to U, down, up U, and from the other side, up to U, down U, up, down. And for last time we will get white correctly on the top. Up to U, down U, up, down, up to U, down U, up. Yeah, and it's done. So whenever you have a parity problem on the top layer at the end, like two corners that need to be swapped or exchanged, you have to, it's a parity problem, you have to break this parity. You do like what we did. In fact, you take this orange, you put it on another side, and then you try to get it from here to there, in fact. So you kick it from its place, you get it on another place, and then you get it back. You manage yourself to take this from here, put it there, and take this from here and put it here with the good orientation. Okay, so this could break the parity problem on the top layer.